Hello everyone, and as always, thanks for joining me today in my shed. This is my small drill press, which I am converting to a small milling machine. And today I would like to make a very simple and mainly cheap DRO. So the first thing I was considering is this, an electronic caliper. This is a very cheap one. I think it costs like €5, but it has some downsides. First, I don't like the material. It's some sort of carbon fiber composite, which means it's flexible, and flexible calipers usually don't work very well. And besides that, I lost the battery. That's why I bought these. These are slightly more expensive, I think €10, but still quite cheap for a well-working DRO. Who needs a manual? Alright, so first things I notice is this is made out of stainless steel, which is always handy. The biggest advantage of this over the cheap one is that this actually does measure up to 1/100th of a millimeter. But how accurate are they, and can I trust them? An ideal way to test the accuracy is using a feeler gauge. So let's just start off with the first one, which is 1.00 millimeters or 40 thou. Alright, that's exactly 1.00 millimeters, almost exactly. Depends on how hard you squeeze it, I guess. Now let's try the thinnest one, which is 0.05 millimeters or 2 thou. Look at that. It's exactly 0.05 millimeters. So I'm quite surprised on how accurate it is, so I guess I'll just use it. First thing I will do is take everything off I don't need. Alright, here we are. I took off everything I don't need. And this is what I'm left with. So my plan is to stick it somewhere right here. So after a lot of thinking, I figured out that this is going to be the final position. I made a few sketches how I want this part, the stainless steel, to connect with the base of the table. It's basically going to be a shape like this, cut out of metal and folded. It will bolt directly onto the table, and then I only need to attach the plastic part to the moving part of the table. Now I will just draw the figure onto this piece of steel. It's quite thick, but at least it will be sturdy.
You just rather watch me fall from a quarter mile. I can see you at the call. Think about it, ring won't tell you what I saw. When you break it off, you'll see who had it all. You had it
Alright, so I think it's about ready to test it for the first time, but let me run through everything I have done. So as you have seen, I've cut off the end of the caliper because this axis isn't that long and I didn't need the length. I need to fine tune it a bit, just see if this setup is correct or if I need to use some washers to space it out. And also I need to figure something out for this end, but I'm not going to bore you with that. This video has taken way too much time so far. So let's stop talking and just see whether it works and if it is accurate. So here we go, let's start turning the handle. And look at that, at least it's giving a measurement. I didn't expect anything different, but yeah, I think that will be useful. So let's do some quick checks. 0 without, then 10 turns. Oh man, look at that, it's reading 17.52 millimeters. So that probably means that I didn't do exactly 10 turns. It will be 9 point, or actually 10.01 turns, but you get the idea, it seems to be pretty accurate. So now let's do another test, and I will zero the DRO. Now I will move the table all the way to the end and back and see if it's still reading 0. So the maximum is 93.45 millimeters and I'm quite happy with that. Right now it's saying 0.01 millimeters and I can move it around a bit, but I'm pretty happy with the result. It took me a long time making this video, so I hope you enjoyed it. Feel free to leave a comment below and of course subscribe. Now for the most satisfying part of the video. Nice. Thanks for watching and until next time.